We are often asked whether logo can also work with a PID controller. What does PID mean anyway? P stands for proportional, I stands for integral, and to me, the D stands for disaster. Controller specialists naturally know that the D stands for the derivative of a control circuit. However, the PID controller causes problems, especially for novices, which means that the control circuit is usually unstable. That is why we have said that for the applications of the typical logo customers, a PI controller is sufficient in most cases. And here is what that looks like with logo. We find the PI controller under the analog functions. It has an array of inputs that you do not recognize initially. You do not need a manual for them, however. You can select the function block and click Help here. Now the complete description is immediately displayed for the PI controller. I don't have to go looking for this in the manual. Instead, I have direct access to the information. Here it says that the PI controller has an AM input, which stands for automatic or manual mode. We do not need the reset input in this example. But we do need the PV input, because the sensor is connected at this point, providing us with the relevant measured value from the control circuit. There are a variety of additional parameters that we will not examine in greater detail at this time. Later you will see why. Here we still have the analog output. There we enter a value between 0 and 10 volts. In our example, the output controls a pump, and we are able to adjust the pump speed. Here the function block is explained in greater detail. Finally, there are parameter sets here for the temperature control, pressure control and level control. There are 2 parameter sets for each, which have developed into typical controller parameters. Now we close the Help menu and return to our program. We connect a switch to the AM input to be able to switch the control circuit to manual or automatic mode. We connect an analog input into the PV input. The sensor would indicate the pressure value as a measured value between 0 and 10 volts. Accordingly, an analog output is connected at the output. This provides the speed set point value for our motor. Now we have to adjust the controller. We can name the module here in order to keep things organized in larger programs. Here there is the sensor type, which we leave configured at 0 to 10 volts. In this area, we could assign the signal parameters. Here we are prompted for the set point value that the sensor is to deliver to the system in order for it to remain stable. In this case, we choose 500, which corresponds to 5 volts from the sensor. And here we should specify the target output value for manual operation. We will use 10% of the maximum speed value. This corresponds to 1 volt. Now comes the important part, the application. Here we choose the pressure we would like to adjust. I simply choose pressure parameter set 2. In this area, values are fixed and cannot be changed. If I would like to optimize the control circuit, I can still select user-defined parameters. Then I can influence the individual parameters. However, we will stick with the default pressure settings. So, now I can test the control circuit in the simulation. The so-called trend view opens up for that purpose. Here we can see that the analog output is now reading 1 volt. And that is the parameter we had configured when the controller was switched to manual mode. If the controller is switched over to automatic mode, the value increases to 10 volts. Why does this happen? Because the sensor currently indicates that there is no pressure in the system. The output value in the trend view increases up to the maximum of 10 volt until I increase the pressure in the sensor in the system. As long as the pressure value in the sensor is below 500, the output value will continue to increase because not enough pressure has been built up in the system. As soon as the pressure value exceeds 500, the output voltage is reduced accordingly. As a result, the pump runs more slowly because the pressure is already too high as it is. Not until I set the pressure value in the sensor exactly to 500 does the output signal become stable, which tends to vary according to the load system. Now we have a value of 338 here. For a different load status, I would have a different output value. It depends on the particular situation. So, typical technicians prefer to set the speed by hand in manual mode using a potentiometer. How can we resolve this? For this purpose, there is the option of connecting a potentiometer in logo. This requires an analog input. I have to run the signal through an analog function block. To do so, I'm using an amplifier. As long as the amplification retains the parameter of 1, the input and output values will be the same. An analog flag is required at the output so that I can download the program in Logo afterwards. In Logo 8, the parameters can be graphically linked to one another. The output value from this amplifier can be switched to the input value for the manual parameter. Following the linking, the value you see has decreased from 100 to 0. In the simulation, I can change the parameter manually with this potentiometer. Because the controller is still in control mode, it has no influence on this at the moment. If I switch to manual mode, the analog output of the controller follows my potentiometer. And then I have the option of truly controlling the system by hand in manual mode. It's that simple to configure control circuits with Logo. Logo. Simply ingenious, simply more.